Hello everyone, welcome back to our channel. Today we are going to discuss about the graphs. What is the importance of the graphs in our daily life, whatever the field? Is it education field? Suppose it is belongs to your height, small baby variations from month to month, and in shades. Easily we can analyze the things with the help of the graphs. If any typical problems also we can solve with the help of the graphs. In any field we require the analysis, means the easy method is we can go through the graphs. But our chapter is motion in a straight line. It is belongs to mechanics. Generally in this chapter, in one-dimensional motion, we are going to discuss about displacement time graph, velocity time graph, and acceleration and time graph. First, for drawing the graph, we require the two parameters. One is along the x-axis and another one is along the y-axis. Mostly on y-axis we are taking the variable thing and the dependent one, and on x-axis we are taking the independent. Suppose we are going to discuss about the displacement time graph. Displacement time graph. See, if the body is at rest, if the body is at rest, how to show this one? We are taking independent quantity on time is on x-axis, displacement we are taking on y-axis. This is the origin. So if the body is at rest, definition is what? Its position does not change with respect to time. Even time is changing, the position does not change. Look here, the body started here. If the line is parallel to the x-axis, you can say the body is at rest. Then one more graph we are taking, average velocity. General formula for average velocity is the ratio of total displacement to the total time. That is called the average velocity. We are taking here also displacement is on y-axis, time is on x-axis. We are taking time is on x-axis. See, the graph is like this. Starting point is at A and ending point is at B. We have to draw one straight line like this. Slope of the graph. Here, slope of the graph is representing with theta. We are taking, this is the theta. Tan theta equals to, here this is the final position and this is the initial position. We can take it, this is S2 and this one is the S1. S2 minus S1 divided by final time is the, we are taking T2 and starting time is we are taking T1. T2 minus T1. It should be right. Change in displacement, otherwise displacement by time interval. So total displacement by total time. How we can find out from the graph? Slope of the graph is giving the average velocity. One example also we are taking. Slope of the graph is nothing but theta. Simply we are taking one straight line that is connecting from initial to final position. How much angle it will make, we are considering theta. So x2 minus s1 by t2 minus t1, delta s by delta t. This is representing the average velocity. Now we are doing two problems based on this. See, this is time and this is the displacement we are taking on y-axis and this is the origin. Here, if theta 1 equals to 30 degrees, this is the first body velocity we are taking, and theta 2 is 60 degrees. This is representing the V2. In this graph, suppose two cars are there. First car is moving with how much velocity? V1. Second car is moving with how much velocity? V2. So without no, we don't know the velocity, and we don't know the time, we don't know the displacement, but we know the slope of the graph. From the slope of the graph, we can able to find out the velocity, and we can able to find out the velocity of the second car also. Look here, V1 makes how much angle? Slope of this one is how much? Tan 30 degrees. Tan 30 is 1 by root 3 meters per second. If it is in meters, and here unit is in seconds. Like that V2, this second one, slope of the graph is tan 60, root 3 meters per second. So from this you can go through the comparison also. Which car is having more velocity also we can say. Which slope is more here? Tan 60 is more, tan 30 is less here. So V2 velocity, V2 is greater than V1. Like that we should find out the ratio of these two. V1 by V2 equals to 1 by root 3 by root 3. We can do 1 by 3. This is the ratio, no unit for this. So slope of the graph is giving, slope of the displacement time graph is giving the average velocity. So we can correct the initial point and final point, how much angle it will make with x-axis, that is giving the velocity. One more problem we are doing. Suppose here we are taking, this is the time and this is the displacement. It will make an angle 45 degrees. In this case also we should find out the velocity is tan 45 degrees. This is 1 meter per second. 1 meter per second. Particle moving with constant velocity. How to draw in this case displacement and time graph? Look, suppose we want to show here S equals to S0 plus Vt. S0 plus Vt. We are taking displacement is on y-axis, time is on x-axis. This is in meters and this is in seconds, and this is the origin. Here initial position is not equals to 0. Initial position is not equals to 0, and that too it is moving with constant velocity. Slope is not changing from point to point. Here if we consider this is the initial position, like it is 4 meters, 5 meters, like that means the graph is starting like this. Graph is starting, it is moving with constant velocity. Why? Here theta is less than 90 degrees. If theta is less than 90 degrees, you can say this is going with constant velocity. The direction is like a positive direction, it is taking this. We can show here S equals to S0 plus Vt. See, particle moving with constant velocity. Here theta, this is the positive slope we are getting. Here theta is less than 90 degrees. Same graph. See, if S equals to S0 minus Vt. How to show this one? Like this we can show this. This is the time and this is the displacement. But here negative slope means we can show like this. This is the S0 minus, this is the S0 minus Vt, and how much angle it will make here? Theta. Here theta is greater than 90 degrees. Here theta is greater than 90 degrees. So here slope is negative. Here slope is negative, and here slope is positive. Here slope is positive. Like that we want to show that S equals to ut plus half at square. This equation also we can show this. Here also we are drawing the graph between displacement is on y-axis, time is on x-axis. Time is on x-axis. The graph is like this. This is the parabolic shape, and it is the inclination. If the like a cup is like this, this is the positive acceleration. If the cup is like this, we have to reverse up that one. Here negative acceleration. What is positive acceleration? If the velocity is increasing. If the velocity is increasing, here that is called the positive acceleration. Like your bike accelerator is there. You are increasing velocity like 20 km/h, 30 km/h, like 40 km/h, like that. So that increasing velocity is called the acceleration. But decreasing velocity is called the deceleration. Later we will show, but you should remember that this is the inclination. If that is like open like that, concave is like it is showing like this, we can take increasing velocity, nothing but acceleration. If it is reverse of that one, you can take that is the negative acceleration, nothing but retardation. The meaning is velocity is decreasing. See, in this case, we can show the graph is like this. Graph is like this. How we can say about this one here? This is the theta one. See, slope of this graph, you know that velocity. We are taking starting point and ending point, that is giving the average velocity. But velocity at particular instant of time, that is called the instantaneous velocity. Tangent at particular instant is giving that instantaneous velocity. Here this is the theta 1 and this is the theta 2. You consider this is point A, this is point C and B, and this is point C. Here also we should draw the tangent like this, theta 3. So here point to point, what happens? Theta 3, slope of the graph is increases. See, theta 1 is greater than theta 2. Theta 2 is greater than, theta 1 is less than theta 2. Theta 2 is less than theta 3. When slope is increasing, velocity is also increasing. So we can show the graph of s equals to ut plus half at square is like this. Then second case, s equals to ut minus half at square. Here also we should draw the graph between time is on x-axis, displacement is on y-axis. We can show this is also declination. Means here suppose this is the point A and this is the point B and this is the point C. How to find out the velocity at point A? We have to draw the tangent and it will make an angle theta. Here also we should draw the tangent. This is the theta 2 and here also this is tangent. It will make theta 3. When you can go through this one, theta 1 is greater than, theta 2 is greater than theta 3. Automatically you can say velocity at A is velocity at B and velocity at C. Like that we can show this. So this is the decreasing velocity. Decreasing velocity is the deceleration. Increasing velocity is the acceleration. But in both the cases, acceleration is